They can strike without warning. Monster waves that unleash hell on Earth.
These are very powerful. We're sort of waiting for the next one.
Tsunamis can be triggered by asteroids. They have been linked to deep-sea earthquakes. And now, a new unimaginable source may have been uncovered. A mysterious island that could spawn a monster wave that could strike 3 continents with unparalleled power. A mega tsunami.
This tsunami scenario is a catastrophic threat.
The event we're talking about would be an event that would change history.
Off the coast of North Africa, there's a volcanic island called La Palma. And this seemingly tranquil setting is center stage to a terrifying story.
Take that landslide model and put it in and...
How big is the landslide?
The authors of this tale are Stephen Ward and Simon Day. These men envision that one day, a monster wave will rise from the water just offshore. It will reach nearly 900 meters tall, and it will have the power to destroy a large swath of North and South America. This nightmarish wave is known as a mega tsunami.
These waves are much larger than anything that any human has seen.
Wow, well, it's pretty serious.
You look up at it and there's this vast thing stretching up into the sky, 3,000 feet high. Imagine a mountain, and then imagine it moving.
The speed of the wave depends on the depth of the ocean. The deeper the ocean, the faster they go.
Hundreds of miles an hour, speeds comparable to that of a jet airliner.
It'll take about 9 hours to reach the east coast of the United States.
But I mean, that's in deep water.
In deep water.
So, and then of course it's going to build up.
So halfway through the ocean, a single original pulse will have spread out into maybe 20 cycles of waves. Usually the biggest one is near the front. When a wave approaches the coast of North America, it's going to grow to about 100 feet high.
Striking the whole western seaboard of the North Atlantic.
It's going to be pretty scary.
All the way from Canada, through the United States, the Caribbean, all the way down to Brazil. So that's going to be big waves in Cape Verde. Well, the event we're talking about would be an event that would change history.
More than half the population on the planet lives along a narrow coastal fringe. The most populated coastal region in the United States, from Boston to Washington, D.C., would take a direct hit from a mega tsunami, threatening millions of lives and the stability of the global economy. If a mega tsunami struck New York City, it would threaten the biggest economy in the United States, one of the largest economies on Earth, and the world's largest stock exchange. Day and Ward's worst-case scenario is hard to believe, but they contend the threat is real, and they have uncovered a line of evidence gathered from remote corners of the world. Fossilized coral, deep-sea discoveries, cryptic clues in caves, wounds in the earth, all support their case and add up to a doomsday disaster of historic proportions.
It's like a big shovel, so this landslide starts to grow.
Only a handful of triggers can unleash the devastating power of the tsunami. Perhaps the most obvious are asteroids, like one called El Tanin. More than 2 million years ago, it struck Earth just off the coast of Chile. With the force of a cosmic bomb. The blast blew a column of water some 3 kilometers high and spawned a series of waves that smashed California, Hawaii, Japan, and Australia. No human has ever witnessed an event like El Tanin. But a second tsunami trigger recently became very real.
Jesus Christ, look at that. That wave is a good 15, 20 feet tall.
In 2004, a tsunami battered coastlines throughout Southeast Asia. In a matter of hours, more than 250,000 people lost their lives. Like all tsunamis, Sumatra was sudden and violent. Its source was hidden, a ticking bomb buried deep within the earth. Like a jigsaw puzzle, the crust of the Earth is made of about 12 tectonic plates. The plates float and move on a molten core, constantly pushing and sliding past each other. The source of the Sumatra tsunami was where the India plate and the Burma plate collide. One plate had been driving deeper under the other, but the two plates had become jammed.
What happens is that there's a slow pressure builds up. This one wants to go by, but it's stuck. And after about 200 years, it finally says, that's enough, and it goes, whoom. It relieves 200 years worth of stress all at once.
As these two plates broke free, one fell, the other snapped skyward. The energy released was 23,000 times greater than the atomic bomb dropped on Nagasaki. The initial wave was hundreds of kilometers long, following the break in the ocean floor. When it struck land, the wave pulsed in, and out, and in again for hours with deadly force.
Imagine a giant out in the middle of the ocean. He grabs the seafloor and lifts the whole seafloor up. And all the water just slides in. There's so much material in it. It's full of stones and sands and debris and cars. People basically get battered to death. They don't drown, they get beat to death.
The 2004 tsunami was devastating, but tsunamis can theoretically unleash even greater tragedy.
The tsunami that we're talking about will be much bigger than the Sumatra tsunami. What we're talking about is the coastline would end up looking like the coastline of Sumatra, a strip of complete devastation, a mile or two deep, spreading from the shoreline inland. Stretching all the way from Canada, through the United States, the Caribbean, and to Brazil, and maybe on the other side as well, in Northern Africa and Europe.
The tsunami threat that Day and Ward fear does not come from asteroids, nor does it come from earthquakes. They suspect that wave will be born from the island of La Palma itself. La Palma is the picture of tranquility. Fewer than 100,000 people live here, in hamlets and villages, tucked in the shadows of a dramatic landscape. La Palma's beauty, however, belies a hidden danger. The southern third of La Palma is dominated by an ancient volcano, Cumbre Vieja. Cumbre Vieja does not look like a typical volcano. There is no large cone. Instead, The volcano is a long ridge that possesses vents and craters. Built over hundreds of thousands of years, Cumbre Vieja appears to be benign. But to Day and Ward, it is locked and loaded to trigger a mega tsunami. But how is that possible? How could a volcano unleash such a deadly oceanic force?
I don't understand at all. The way we envisage that the Cumbre Vieja could produce a giant tsunami is if the side of the volcano splits off and slides into the ocean.
The potential tsunami trigger is a massive chunk of rock. It is approximately 24 kilometers long, 24 kilometers wide, and 3 kilometers thick. And although it looks immutable, if it breaks free, it's built for speed.
At top speed, the flank might be moving at 50 or 100 meters per second. That's express train speed.
According to Day and Ward, the collapse of Cumbre Vieja would be preceded by weeks of violence. Vents along the ridge would send plumes of ash to darken the skies. Lava would pour from fissures and rush down steep slopes to the steaming sea. Hellish fires would burn through forests, scorching the mountainside. Earthquakes would rattle once solid ground, destroying hamlets and villages. And then, slowly at first, as much as 500 cubic kilometers of the island would begin to break free. A wave is born. A mountain range of water that rises more than 900 meters. Within minutes, much of the Canary Islands will be destroyed. An hour later, the mega tsunami will devastate parts of northern Africa and Europe. Before the day is out, North America, the Caribbean, and South America will face monster waves.
Fills the crater, when it goes down through the trees over there.
It's hard to imagine that a volcanic island can trigger a mega tsunami. Asteroids, yes. Underwater earthquakes, we've witnessed. But many doubt a large chunk of Cumbre Vieja will ever fall rapidly into the sea. Is such a calamity possible?
Ladies love strong fragrances. What's the point if you have stained clothes? Nivea for Men Black and White. A great fragrance without the chemicals that cause stains. Prevents white stains and reduces yellow stains. Nivea Black and White. What men want. Berhenti!
Jangan senyum. Saya mau keluarkan uang lah, Toke. Ini kad BSN. Engkau ada?
Mohon, ada kad BSN.
Ejen bank berdaftar BSN. Ada kad.
Dan bila saya dah sah, bukan lagi isteri Encik Nazif, saya akan berhenti. Abang? Abang? Abang, abang? 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 Aku mencari ruang cinta untuk cintaku bagi cinta ini.
Half a world away from the island of La Palma, on the big island of Hawaii, mysterious events are unfolding that make the La Palma threat all the more real. Here, one of the most active volcanoes on Earth, Kilauea, may be breaking toward the ocean, severing its ties to the island. The forces tearing this island apart are perhaps most dramatically seen in a fissure known as the Great Crack. It is nearly 13 kilometers long, 15 meters wide, and more than 16 meters deep. Many believe this wound foreshadows a disaster yet to come. Investigators like Mike Poland are keeping a trained eye on Kilauea. Unlike Cumbre Vieja, it is being closely monitored, and for good reason. Using GPS sensors, Poland is tracking an epic movement on the southern section of Kilauea that's invisible to the naked eye.
The south flank motion is constant. It occurs at about 3 or 4 inches a year. And it's steady and inexorable. It's always happening. So even if you're standing on the south flank for only a few hours, during that few hours, the south flank did move towards the ocean, a very small amount. And it's hard to get a sense of that when you're out there because it's so big and so solid and so massive.
The movement of the south flank, like the hands of a clock, is steady. But not long ago, scientists discovered that flanks like Kilauea and Cumbre Vieja can move suddenly and rapidly.
In November of 2000, there was the first recognized instance of what we call a slow earthquake or a silent earthquake. And that's when the entire south flank of Kilauea lurches over the course of about 24 to 36 hours towards the ocean by about 1 or 2 inches. And so you're talking about the entire flank of a mountain, and that's millions of tons of rock moving all as one piece towards the ocean. That is rocket speed. That's extremely fast.
The movement of the south flank was so unexpected that at first scientists thought there was a mistake with their data.
It took some period of time to recognize that this offset, this motion that had occurred was real. It actually took a while to recognize that this event happened. This had never been recorded on any other volcano before.
7 days a week, 24 hours a day, Kilauea is being scrutinized by a vast system of automated sensors. Field surveys serve as a backup in anticipation of the next surprise move.
It's hard to say whether Kilauea's south flank would be one of these catastrophic failures or whether it's just going to creep along as it is now. A flank failure is something that's so big as, for me, to be incomprehensible. It's like an asteroid hitting the Earth. I have a hard time wrapping my mind around just what might happen if that were to occur.
Although it may be hard to imagine, there are clues suggesting that Hawaiian flanks have failed in the past, and that they've triggered monster waves. You just have to know where to look. On the nearby Hawaiian island of Lanai, Gary McMurtry is searching for tsunami victims. His quarry? Ancient coral, whose broken bodies provide testimony to an actual disaster. Coral reefs rim the islands of Hawaii like jewels of a crown. They provide home to a menagerie of fish and invertebrate species. While appearing static, corals do grow and expand their ranges, spreading out on the sea floor. They are typically found firmly anchored from shallow waters to depths of 39 meters. Investigators, however, have been finding ancient coral on land, which is not unheard of. But what is surprising is where they've been discovered. On the island of Lanai, far from the shore, on mountainsides, more than 300 meters above sea level, investigators have found coral reefs. How the corals got here is a mystery.
I think the mystery with the particular deposits we're talking about in Hawaii is that they're just so bloody large. I mean, these are not small deposits, and because of that, I think a lot of people have a hard time wrapping their head around the size of it.
At first, people thought the reefs are high because long ago, sea levels might have been higher. Others suggested the reefs were lifted from the ocean as the islands grew. McMurtry suspects another culprit and points to a telling clue.
Look at that.
The coral is not intact. It is highly disturbed, as if it were thrown here.
They're, a mixture of terrestrial and marine. It's a hodgepodge. Sometimes it's reversely graded and the boulders are up on top instead of on the bottom. And it's a topsy-turvy kind of deposit.
McMurtry thinks there's a more likely explanation for the coral deposits. There's another mechanism that could have smashed coral onto the side of the mountain. A major tsunami. And if that were the case, McMurtry believes the tsunami would have left other clues. On the seafloor surrounding the Hawaiian Islands, researchers have found a massive mound, a geologic formation spanning more than 8,300 cubic kilometers. At first it was considered an underwater mountain, but now it's widely accepted that it's the remains of a volcanic landslide. To get a sense of the scale, consider the eruption of Mount St. Helens. May 18th, 1980. At approximately 8:30 in the morning, Mount St. Helens exploded in a violent eruption. The event is the deadliest volcanic eruption in U.S. history. It also triggered the largest recorded volcanic landslide ever witnessed. The slide was enormous, but the slide off the coast of Hawaii is more than 400 times larger.
There's the event. You have the initial wave. Huge wave hits the west coast of the Big Island. We dropped a big hunk of the island of Hawaii onto the seafloor.
Computer simulations of the slide reveal that it would have produced a series of tsunami waves that drowned the Hawaiian Islands. The slide has been named Alika 2, and McMurtry suspects that it ripped entire coral reefs off the seafloor and then plastered them onto the mountains.
This is Koholave. Look at that. It's just practically completely inundated by some of these waves. The tsunami waves completely sweep the beach. I mean, we're talking about the composition of the beach, and that's what we see. We see everything. The sand that was there, the sand that was offshore, the pebbles, the boulders, the coral heads, all that stuff is thrown up on land. Now, the reefs are completely wiped out every time this happens. I mean, these are very powerful, very powerful.
If Alika 2 did create the coral deposits, McMurtry knows there's one fact that would make the case. The age of the slide would have to match the age of the coral deposits. To date the slide, McMurtry measured the amount of marine debris that has rained down and collected on the underwater deposit over millennia.
Think of it like dust on an old piano. It accumulates, and you can figure out how long the piano's been there because it's got so much dust on it, right? And you can do the same thing with these big landslides.
In his lab, McMurtry prepares ancient pieces of coral for dating. The corals are weighed, cleaned, and pulverized. When McMurtry compared the dates, he found what he was looking for. The date of the Alika 2 slide and many of the coral deposits coincide.
All the evidence points towards large tsunamis, very large tsunamis. That's the only thing we can think of that would produce this. It's not a debate anymore. It's for sure a tsunami deposit. What else could it be?
It's now clear to investigators like McMurtry that volcanoes can trigger tsunamis, and scientists are continuing to find evidence in Hawaii for ancient tsunami events. McMurtry thinks it's time that the threat of a volcanic flank failure, like the one posed by La Palma, should be taken more seriously.
Volcanic flank failures have not been on the radar as much as other types of phenomena. People know that there's earthquakes and earthquake-generated tsunamis, but in fact they're not even the biggest tsunamis. Compared to what we study on these volcanic flanks, they're kind of small. We're sort of waiting for the next one.
The cause of a volcanic flank collapse is still a mystery. Perhaps it's the sheer mass of the flank being pulled by gravity. Maybe it's magma, permeating cracks and fissures that push the flank free. In a search for clues, investigators race to where few have gone before, into the hearts of volcanoes. Back in the Canary Islands, on La Palma, Simon Day and Steve Ward make their way into the dank recesses of a dormant volcano. A vast system of tunnels has been excavated here in order to access reservoirs of fresh water.
One of the really surprising things that we see on La Palma is the amount of water that's present inside of the volcano, and it's actually quite important for the local economy.
The water extracted from the mines is the primary source of water on La Palma. But for Day and Ward, the water also poses a threat. They believe water is critical to their doomsday scenario. It is water that could ultimately push the western flank of Cumbre Vieja into the ocean, triggering a mega tsunami. Cumbre Vieja is saturated with water. The water is capped at the top by thick layers of ash and rock. Sheets of lava, called dikes, trap the water from the side, virtually sealing it in place. This trapped water could act like a bomb in a future eruption.
Water comes filtering down from the surface through these rocks down to this level. It would try and move sideways through the rocks, but it can't because it runs into this sort of rock. This is one of the dikes that intrude the volcano. These dikes within the volcano are trapping water between them. Then another eruption occurs. More magma is coming up through. The magma in the new dike is very hot, 2000 Fahrenheit. So it heats the water. If the water was able to escape, it would just flash to steam. But of course it's trapped between the dikes. So it's like the water is in a pressure cooker. You heat the water, the pressure goes up. And it's that extra pressure pushing on the rocks to either side that we think is going to be the cause of the flank of the volcano eventually collapsing in some future eruption. Very porous material, there's lots of water in there, and so when the dike comes in...
Day and Ward suspect that pressurized water could be the death nail for Cumbre Vieja, the final push. That's because Cumbre Vieja may already be showing signs that it's breaking free toward the sea. For more than 36 days in 1949, Cumbre Vieja violently erupted, blowing open craters and sending waves of lava to the sea. The south of the island was also rocked by massive earthquakes. Among the last craters exposed is arguably the most dramatic, Hoyo Negro. Like an open wound, Hoyo Negro is a striking reminder of the violence of the 1949 eruption. But within this crater, there's a far less obvious yet more profound scar. The western side has dropped measurably to the sea.
And if you look there, you've got that yellow ash layer with the black band in the middle of it. And you can follow the black band along the cliff face, and then it drops down 6 feet to the west, and you can see it cutting the little black bands.
The western side of Cumbre Vieja appears to have been cut free from the island. The volcano may have been severed by a fault that runs along the ridge of the mountain for more than 3 kilometers. For much of its length, the fault is hidden, buried under rock and stone, just beneath the surface of well-worn footpaths. But the fault does periodically break the surface in plain sight. And when it does, the story is always identical. To the west of the fault, the island has dropped measurably.
It's exactly the same as before. The western side here has gone down by a couple of meters relative to the east side.
Critics contend this is not a fault, but a mere surface crack. Day and Ward disagree, and they point to compelling evidence. Like a fault, the fissure runs a consistent and direct line. The western side of the fissure is always moving toward the sea.
So in fact, it happened during the earthquake. It's long and straight. When you walk along that crack and measure one side to the other, you get a consistent offset and a consistent sense of direction. As an earthquake seismologist, that's very convincing.
If the fissure was merely a crack that appeared during the earthquake, Day and Ward suggest there'd be cracks all over the island. The volcano's surface would look like a shattered windshield. And this is not the case.
If the structure up the top that formed in 1949 was just surface fissuring rather than a fault cutting down deep into the volcano, then we'd expect to see similar fissuring all the way from the summit down here to the coast. And especially here in the cliffs, we'd expect to see similar fissuring in these rocks in the cliffs here. And we just don't see that.
To these investigators, Cumbre Vieja is vulnerable. Collapse may not be imminent, but it is inevitable. Some of the most provocative evidence is best considered from the air. Throughout its history, the island of La Palma has been a stage of dramatic change. Cliffs have sloughed to the sea. Giant holes have been blown open, leaving gaping craters. Day and Ward believe that La Palma's unique past could have a dramatic impact on our world. To the fates of cities and to countless lives an ocean away. The wheels of their doomsday scenario were set in motion a long time ago. La Palma was once home to another volcano called Cumbre Nueva. Its reign came to an abrupt and violent end some 560,000 years ago, changing the face of La Palma. After the collapse, a series of vents emerged, creating 3 rift zones. As lava poured from the nascent rifts, it gave rise to Cumbre Vieja. Cumbre Vieja's formative years are critical to Day and Ward. That's because the western flank was built on rubble, the remains of Cumbre Nueva. This makes the western flank inherently unstable. But what's more critical is that over time, the rift zones transformed. First, the northwest rift became inactive, followed by the northeast. Today, the north-south zone stands alone. It is now the only outlet for eruptions, threatening to tear the island apart. This pattern of zone reduction is seen again and again in the geologic record, just prior to volcanic collapse.
Right, so Steve, what we're doing now is we're flying up the north-south rift zone, and this is the one that's active now. So what we can see here is Crater of Fraile, Hoyo Negro, Nambroke, all defining this north-south line of volcanic vents that's cut north through the volcano over the last few thousand years, and that's all parts of the reconfiguration of the volcano. This reconfiguration seems to be a sign that a collapse is impending. What we see as a pattern on these island volcanoes is that there's a fundamental structural reconfiguration with a reduction in the number of rift zones before the collapses occur.
Today in Ward, the active rift zone is acting like a bulldozer, pushing the western side to the ocean.
It is very dramatic. All these years we've been modeling this on my computer. Wonderful to see it in real life.
Yeah, there it is.
Very cool, very cool.
The evidence gathered in the field clearly points to a threat. In some future eruption, Cumbre Vieja could fail catastrophically. And if it does, the western flank will tear into the sea. But will it trigger a mega tsunami that will devastate shores half a world away? How do you calculate the impact of a wave no one has ever seen?
Sitting at 145 wave analysis, whenever it's time for the pneumatic cylinder.
The O.H. Hinsdale Wave Research Laboratory at Oregon State University houses one of the largest tsunami generators in the world. Tsunami scientists like Herman Fritz flock here to see the unseen.
The tsunami scientists, we are likely never to actually see a tsunami wave, no matter how many times we go into the field. One of the closest things we can get is really in the laboratory to do a large-scale experiment to try to reproduce some of these scenarios and see those tsunami waves at smaller scale in the laboratory.
Coming down in 15 seconds!
In my lifetime, I've probably seen hundreds of laboratory-scale mini-tsunamis, which have to be scaled up by factors of 100 to 1,000 to get to full scale.
As part of his work, Fritz is investigating how far a tsunami can travel and still pack a deadly punch.
Yeah, we're missing part on the MTA. I think we got pretty good coverage to the side.
Answers to this question depend on how wavelength tsunamis can travel thousands of kilometers and maintain their destructive energy. The collapse of Cumbre Vieja will be different. It will produce waves with short wavelengths. It's thought waves like this will spread out and lose their destructive power as they cross the Atlantic. In the lab, the team prepares to model the collapse of Cumbre Vieja. Will the ensuing tsunami maintain enough strength to destroy distant cities?
We've set up a landslide tsunami generator which represents sort of the western flank of La Palma. So we have this capability to launch a large mass of that volcanic island into the wave basin, which represents the Atlantic Ocean. And then, of course, on the other end of the wave basin, we have the U.S. East Coast, which we've mimicked with the run-up ramp. And the big question is how much of that wave energy and in what form will that wave arrive on the east coast of the United States? Will it just be a ripple that washes the beach, or will it potentially be more damaging?
Okay, all clear. Ready for launch.
Again and again, Fritz and his team create the collapse of Cumbre Vieja, captured by an arsenal of cameras and sensors. results are telling.
What we're finding here is that we get a gigantic wave, a wave bigger than any wave we've ever seen in recorded history at the source in La Palmas. We have the entire western flank collapse catastrophically, attaining very high velocities at once. We get a very big wave locally.
At first, Fritz's data supports Day and Ward's doomsday scenario, but there's a catch. Experiments reveal that as the initial wave moves from La Palma, it will form dozens of waves. As the series of waves spread out, they will rapidly lose power. When the waves reach the distant shores of the Atlantic,
you'll have a series of waves approaching the U.S. East Coast, but they're most likely going to be significantly smaller compared to the original wave height at La Palma. The wave heights are most likely going to be on the order of a few feet, not necessarily catastrophic.
The potential disaster posed by Cumbre Vieja could be epic to the local islands, threatening tens of thousands of people. But could the wave really lose its power by the time it reaches the eastern seaboard of North America? Simon Day and Steve Ward don't think so. They believe their worst-case computer models are accurate.
20, 30, 40 meters, it comes in shore, same as Caribbean.
That's the shoaling effect.
They contend tank models are extremely valuable, but they can't match the complexity captured by the computer.
I do physical simulations. That means using the laws of physics to the best I know them, which means gravity and friction and wind resistance. And you put that into a computer and let it go. It's always impressive to see how much of the coast gets. I mean, Sumatra got... We've had many criticisms of on our work over the years. If the volume is what we say, and if the speeds I think are going to be what we say, I'll stick with my guns here.
Yeah, this is the one that we use to...
Day and Ward's confidence is not false bravado. They believe their model can accurately predict a future tsunami because it has successfully simulated events from the past. On March 13, 1888, in Papua New Guinea, Ritter Island volcano violently erupted, and roughly 1 cubic mile of its side fell to the sea, marking the largest lateral collapse in recorded history. The collapse triggered a massive series of waves approximately 15 meters high that crushed shores hundreds of kilometers away. Day and Ward's model matches eyewitness accounts with striking precision. But there's more. It appears tsunamis with short wavelengths can maintain their power over great distances.
So you take that landslide model, put it in, and...
In another test, they used their model to simulate a second, more recent tsunami. In July 1958, in Lituya Bay, Alaska, a landslide sent as much as 53 million cubic meters of rock crashing into the water, triggering a tsunami. The waves surged over the opposite wall of the inlet to a maximum altitude of 524 meters and rocketed through the bay at speeds reaching 96 kilometers per hour. Again, Day and Ward's model captures this event with precision.
So the model really works, it really gets it right. And that gives us confidence that the model is successfully predicting what a collapse of La Palma might produce in terms of a giant tsunami.
If Cumbre Vieja does collapse, it raises a profound question. What, if anything, can we do in the face of catastrophic destruction? In the United States, natural disaster planning falls upon the shoulders of local authorities. In the city of New York, any disaster alarms would begin to ring here.
155 West 6th.
The Office of Emergency Management, also known as the city's nerve center.
Watch Command is our 24-hour warning point. They are monitoring electronic communication in the city and outside the city and around the world all day, every day. We get paid to think about the worst-case scenario and to plan for it. Disasters are our business.
At OEM, responders are on guard for all manner of deadly threats. Terrorist attacks, riots, and natural disasters like earthquakes, storms, and tornadoes are all on their radar.
Amsterdam's the cross, no second cross. So far, no injuries.
Given the city's geography, hazards born of the sea also pose a deadly risk.
New York City is 8.4 million people living in 300 square miles. We are 3 islands and a peninsula, about 50 feet above the water. So we are vulnerable. This tsunami scenario is a catastrophic threat to New York City. And it is a low probability, but high consequence event. Therefore, we are thinking about it, and we are planning for it. We own the problem.
If Cumbre Vieja were to begin erupting and earthquakes rattle the island, emergency planners in New York and the mayor's office would be faced with a difficult problem. If and when do they issue an evacuation? People living in low-lying areas like large swaths of Brooklyn, Queens, and Lower Manhattan would be the most vulnerable to killer waves. Getting all residents to safety could take up to 18 hours. If officials wait until the tsunami is triggered, the evacuation would be a race against time. That's because the wave would rocket across the Atlantic in as little as 9 hours. And it may strike before many are safe. On the other hand, if the order to evacuate is given too soon, and an eruption of Cumbre Vieja does not lead to a collapse, the financial cost of a false alarm would be staggering.
55 hours. This is OEM base, about to commence with the health and medical roll call. Montefiore Medical Center, Moses Division.
At OEM, the lives of millions are at stake.
Bronx Lebanon Hospital Center.
An evacuation is their ultimate test.
Calvary Hospital.
An evacuation order is one of the toughest orders that a mayor can give because, especially in New York City, it affects hundreds of thousands and even millions of people. Jobs can get very big very fast. In a disaster, that's when confusion sets in. Our job is communication coordination.
In an evacuation, the New York Stock Exchange would go digital. Ports would be locked down. Businesses closed. There are 3 evacuation zones. People in floodplains would get the order to evacuate first. Residents would be instructed to report to evacuation centers. From here, they would be routed to shelters. The primary conduits to safety would be mass transit. The city's veins and arteries, which pulse in and out of New York, would be redirected to flow inland. The city's fire department would be called into action to evacuate hospitals, nursing homes, and those with special needs. The NYPD would be charged with enforcing the evacuation order. As thorough as plans are, success depends on execution. And questions remain. How many people would be left behind? How many would survive a mega tsunami? Today, the island of La Palma is quiet. The volcano is at rest. The ground is still. But even now, it has much to say. Investigators are coming to recognize that seemingly immutable volcanoes do move. And when they do, they have the power to change the world. Will future eruptions cause Cumbre Vieja to fail catastrophically? Dayan ward caution against both alarmists and those that would dismiss the threat.
The key question, of course, is when is this collapse going to happen? When is this giant tsunami that we're predicting going to strike all around the North Atlantic? And we just don't know the answer to that. There's going to be a real need to closely monitor the volcano during its future eruptions.
La Palma is just one of the volcanic islands of the world. So La Palma is high on the list, but it's not alone on the list.